All right, welcome to 7.4 video. Starting on page 172 of your notes packets, we're looking at systems of inequalities in two variables. Okay, so our first objective is to graph inequalities in two variables, and our example is to solve the given system. Now, anytime you have a system of equations, you're looking at these as if it was an AND statement. So our results have to satisfy all four of those inequalities. Okay, I'm going to start with the ones that look kind of the simplest. If we're looking at x is greater than or equal to 0, what that tells me is I have to be where x values are positive. So if I sketch here a coordinate plane, my x values on my x-axis are positive in quadrants 1 and 4. Remember, 1, 2, 3, 4. So in quadrants 1 and 4, my x values are greater than or equal to 0. My y values are greater than or equal to 0 in quadrants 1 and 2. Now, because this is an AND statement, it has to satisfy both. So what this tells me is that I'm only looking for solutions in quadrant 1. I don't even have to worry about the other 3 quadrants. So now I can go into looking at these other 2 inequalities here, knowing that I only care about their solutions within quadrant 1. Okay, so to look at the first inequality, and I'm going to move the camera down here. To look at the first inequality, 2x plus y is less than or equal to 10. We first want to find our border, or our borderline. So we want to write this as a line. So 2x plus y equals 10. To graph the line, we could put it into y equals mx plus b form. So subtract 2x over y equals negative 2x plus 10. Our y-intercept here at 10 with a slope of negative 2x, so down 2 over 1, is going to look something like this. Okay, now when I'm graphing the line, I graph it solid because this is a less than or equals to. If it was just a less than, then I would graph it dashed. And I'm looking for points that satisfy this inequality, so I'm just going to test. I don't know if it's on the kind of top right side or the bottom left side of that line, so I'm going to test 0, 0, the easiest number to test. So 0 plus 0 is less than or equal to 10. 0 is less than or equal to 10 is true. So my solutions are on this side of the line. And remember, I'm only looking in quadrant 1. For the second inequality, we have 2x plus 3y is less than or equal to 14. Again, I'm going to look for the boundary line. So 2x plus 3y equals 14. Subtract 2x, so 3y equals negative 2x plus 14. Divide by 3, y equals negative 2/3 x plus 14/3. Okay. So what I end up with is 14/3 is about 5. So that would be my intercept with a slope of negative 2/3. So down 2 over 3 would give me something like this. Okay. Again, I'm going to test the origin for my point to see if it satisfies my inequality. So 0 plus 0 is less than or equal to 14, and that is true. So I would shade this side. We're shading the side of the line that includes the point 0, 0. Okay, so my final region of solution is this quadrilateral. Looking at example 2, you're going to follow the same steps. However, notice our first inequality is nonlinear. So you're going to graph, this is the shape of a parabola, dashed, and then the dashed line, and shade the region that satisfies both inequalities. And lastly, example 3, solving the system of inequalities in two variables, problem solving. So we're going to look at this word problem, set up our variables and then our system of equations and solve the region that satisfies all of those equations. So I'm going to let you go ahead and do this on your own, think back over the lesson, and then summarize what you learned in the box below.